Okay, welcome everyone. This is the second lecture of the topic, the properties of material. The first one I have already uploaded, which was on the electrical properties of material, and the second one is about the magnetic properties of material. And both of these properties come as physical properties of materials. Okay, so let's start this lecture. And it is a lengthy one, so be patient and be patient while attending this lecture, and also try to understand the concept behind the magnetic properties, the various magnetic properties of material. Okay, so there are various application of this magnetic properties, the hard disk of your laptop and computer system. Okay, so these all are by the virtue of these magnetic properties that you apply in these materials, in these devices. Okay, the content of this today's lecture is the concept of magnetism, and then the classification, that is di, para and ferromagnetic materials. Then there is something called hysteresis. What is the hysteresis loop? And what is that soft and hard magnetic materials, how they are applied, what will be the soft material and what will be hard magnetic materials, and how they are different from each other. And the remaining topic and last one is the superconductivity, and this superconductivity includes both the phenomena, means electrical properties and as well as the magnetic properties. So we are discussing it after completing the video. Okay, so let's start one by one, we will go through. Okay, so you just listen to you this lecture and try to understand the each and every phenomena. So first of all, what is magnetism? Okay, so magnetism is that certain materials, certain class of materials, they shows this behavior of magnetism. Okay, from thousands of years, it is not a new phenomena. Okay, from thousands of years many materials has been showing this behavior of what you call magnetism or the magnetic property. Fine. So then we find out that there is something called magnetic properties in several materials, and that class of materials is known as the magnetic materials. Okay, their classification and everything comes after that. First of all, you will means try to know that what is the theory and what is the principle behind this magnetic property in a material. Okay, means the material that shows magnetic properties without any application of magnetic field or any application of electrical field. Okay, and by this means magnetic materials, you apply these kind of materials in many application like power generation, transformer, okay, electrical motors, and yeah, and radio, television, telephones, computers, like this. Okay, so these have a vast application in many things. Okay, just a minute, this fan is not working actually. Just a minute. Yeah. Okay. Okay, so these all are the application, and this property of magnetic behavior is known from thousands of years. It is not something new. Okay, the advancement in this is happening day by day, and still it is going on. Okay, and there are many challenges still there, so that is continuous process. Now how this magnetic property developed, and how we can see that there is something called magnetism in normal material. Okay, so that is a normal material. uh, it is a iodine stone, for example. Okay, because some iron and some steels and some naturally occurring minerals, iodine stone, these are the well-known examples that exhibit some magnetic property. So let's suppose it is a magnet, so it will has a north and a south pole. Okay, and you will have these kind of magnetic lines which will start from north pole and will and at the south pole. Okay, this is for a material, a magnetic materials which exhibits a magnetic behavior at normal condition. Okay, similarly, if you if you pass a current in a coil of this, okay, so you will also have a magnetic field around this current carrying coil. Okay, so in this way you can also develop the magnetic field, and that is also similar to this. Okay, here you are passing the current and here you are not passing any current, you have this magnetic behavior without any application of current. Okay, so what is the difference between these two? Okay, both of these are the magnetic behavior, there is no doubt about it, but there is a difference that we will uh, come in the further slides. Okay, so before means before describing the means behavior of this or the origin of the magnetic moments in a solid materials, we need to know certain parameters. Okay, or you can say certain magnetic field vectors. Okay, to know this origin of magnetic theory. So one of them is the magnetic field strength, which is denoted by H. Fine, and this magnetic field strength H can be calculated for a current carrying coil if it is having n number of turns and length is L and the current magnitude is I. So H will be equal to Ni upon L. This is the magnetic field strength. Okay, H, and the means unit of this H is ampere turns per meter or simply amperes per meter. This is the first field vector H. The second field vector, that is known as the magnetic flux density. Okay, and it can also be called as magnetic induction. It is denoted by B. Fine, and this B, it actually depends. Okay, it actually depends on the value of H. Okay, means you are applying this H magnetic field strength to the material, then there will be a magnetic induction in the material, and that magnetic induction or the magnetic flux density is B. Simple. And the unit of this B is Tesla, or it is there is also another unit that is known as Weber per square meter. Okay, and both these B and H field vectors being characterized not only by magnitude but also by direction. Okay, so they are a field vector, they are not field scalar because they need the magnitude as well as the direction. There is another important formula, is the relation between B and H. Okay, so B is equal to mu into H, where mu is the permeability of the space. Okay, the mu is called the permeability, and which is the property of a specific medium.